Previously, we learned how to use Greenfoot by observing pre-existing Greenfoot scenarios. We learned to create objects from classes and call methods. We learned that an object's methods are commands, questions, or requests for information about the object. Now let's begin learning to create our own scenarios. Let's begin by opening the little crab scenario. As usual, we see the world and actor classes and their respective subclasses, crab world and crab. Let's put a crab out in the world. If we click the Run button, the crab does nothing. This is because there's no code in the crab class act method to make a crab do anything. We're going to change that. Let's open the source code for the crab class by double-clicking the class name. This is the definition for the crab class. In other words, this is the underlying source code that constitutes the blueprint for creating a crab. Not everything is here. Some of the blueprint comes from the actor superclass. Notice the line public class crab extends actor. This is how we create a class in Java. Class crab defines the name of the class. Extends actor makes crab a subclass of actor. Think about it. A subclass is an extension of its superclass, so the word extends makes sense. The class definition includes the class header and the body defined by opening and closing curly braces. Inside the class body, we can put methods and variables as needed. Let's look at the act method. Remember, the act method is called every time the act button is pressed, or continuously when the run button is pressed. So the act method is really important in controlling how an object behaves when the scenario runs. The method definition includes the header and the body defined by opening and closing curly braces. Notice the line inside the act method with the gray text. It begins with 2 forward slashes. 2 forward slashes indicate the start of a single-line comment. Single-line comment means everything on this line that appears to the right of the forward slashes is a comment. Comments are to be read by humans to give them additional information about the code. Java completely ignores comments. Notice it says, add your action code here. In other words, we can put some code here, either below the comment or in place of the comment. Let's put it in place of the comment. It's important to write this exactly as shown, then click the Compile button. This line is referred to as a statement, which is an instruction to do something. Statements in Java end with semicolons to mark the end of the instruction. Move is a method that can be called on crab objects. In this case, we put 5 in the parentheses, which makes the crab move 5 pixels to the right every time the crab's act method is called. 5 was picked arbitrarily. We could have used any valid integer. How did we know we could use this move method? Well, it isn't a method defined in the crab class. One way we know that is by looking at the crab class source code. Move isn't there. Move is actually defined in the actor class. Remember, a crab is an actor and inherits methods from the actor class. One way to see move is to right-click a crab object and view its object menu. Under Inherited from Actor, we see Void, Move, Int. Remember the wombat? If we look under Inherited from Actor, we see the exact same list of methods. Since crabs and wombats are actors, they inherit all of the same methods from the actor class. Back to the Move method. We know from previous discussion that a void method is a command to the object to do something. We know that the int inside the parentheses means we have to put a valid integer inside the parentheses, since the move method has an int parameter. The name of the parameter doesn't show here, but we'll see it in a moment. Another way to see actor class methods is to double-click the actor class name in the class diagram. Because the actor class cannot be edited, we see a documentation view instead of the source code like we saw for the crab class. This view gives us a detailed list of all the methods in the actor class. We'll learn many of these methods as we go through the course. Again, these are available to the crab class by way of inheritance. Crab is a subclass of actor and inherits actor methods. Clicking Move gives us all the details about the move method. Notice the description for the distance parameter. It states that negative values move the actor backwards. Let's try it. Just below Move, we see the specification for the turn method. Notice the description for the amount parameter. The number of degrees to turn, positive values turn clockwise. We also see that amount must be an integer. It represents 360 degrees of turn, so it can be any integer from 0 to 359. Even though the description doesn't specifically say so, I know this is true because I previously dug further into the code. This is an example of where documentation or commenting could be improved. Again, comments help humans understand your code. Let's add turn to our code, just below the move method. We'll have the crab turn 3 degrees. Now we have two statements within the act method. The crab moves 5 pixels right, then turns 3 degrees clockwise. Why? Because we put the statements in that order within the act method. That's important to know. Statements are executed top-down in the order we place them. Let's temporarily remove the move method from our code. We could delete it, but we don't have to. We can simply comment it out. Remember, 2 forward slashes begin a single-line comment, meaning everything to the right on this line is ignored by Java. So this former statement is no longer considered a statement, just a comment. Now the crab turns 3 degrees at a time, causing it to spin in a circle. If we click the Act button, we can see this step by step. When we click the Run button, this happens so fast it looks as if the crab spins in one fluid motion. Let's try it with 270 so that he turns 270 degrees at a time. Notice the crab appears to spin much faster. If we use the Act button, we can see how much the crab spins at a time. Let's change it back to 3 degrees of turn and bring back the move method. Bringing back the move method is as simple as removing the 2 forward slashes. When we write code, we have to be careful to use the correct syntax. Syntax is equivalent to spelling and punctuation. For example, we know a statement ends with a semicolon. If we leave off a semicolon, it causes a syntax error. Note the changes in the editor that indicate an error with the class. Notice the red underline at the far right of the statement. Hover over that, and an error message will display saying semicolon expected. The solution is to replace the semicolon and recompile the class. When an error occurs, observe the message and try to fix the code. Then be sure to recompile. You may have to repeat this until all errors are gone and the code compiles correctly. Be aware the error may not be on the line where the error is flagged. Usually it is, but it may be on a line before that. By the way, when an error prevents the code from compiling, this is referred to as a compile time error. We'll discuss logical and runtime errors later. Let's remove the turn method from the crab class. Now the crab stops when it reaches the edge of the world. Why? Because at this point our act method only tells him to move 5 pixels to the right. The crab doesn't know how to do anything else, such as turn. We can make it so the crab knows it's at the edge of the world, then moves in a different direction. To do that, we should look at the methods available to a crab. We know the only method currently defined in the crab class is the act method, so there's nothing of use there. Again, we go to the actor class, which is a superclass of crab. Scrolling through the documentation, we see is at edge. The comments indicate that this method detects when the actor is at the edge of the world. This further demonstrates the importance of documentation. When faced with a new problem, read through the documentation to see if there's code already available to deal with it. There's no need to reinvent the wheel. Notice that the return type for is at edge is Boolean. We already know that a Boolean can be either true or false, and a method that returns Boolean is like a question. In this case, the question regarding our crab is the crab at the edge of the world? We also know that since the parentheses for this method are empty, it has no parameters. This means it needs no extra information, so we put nothing inside the parentheses when we put it in our source code. If we right-click the crab and select its isAtEdge method, we see from the dialog box that it returns false. If we drag the crab to an edge of the world, then repeat the previous step, this time it returns true. How do we make this a more permanent part of our crab? We write code in the crab class. Again, the act method controls the behavior of the crab, so we need to put the code inside it. The goal is, if the crab is at the edge of the world, we'll have it turn and continue moving in that direction. If the crab is not at the edge of the world, just keep going. This is key. If the crab is at the edge, turn. So we need to have the crab make a decision. The basic decision-making structure in Java is the if statement. The generic layout of an if statement is this. The parts in italics should be replaced with actual code. If the condition is true, then the statements inside the if statement are executed. The body of the if statement is defined by the opening and closing curly braces, so any statements inside those are executed in order when the condition is true. If the condition is false, the body is completely skipped. In either case, any code that happens to come after the closing curly brace of the if statement then continues normally. Let's put an if statement inside the act method. In this particular case, it doesn't really matter if we put it above or below the move statement. Notice the isAtEdge method is inside the parentheses for the condition. Remember, isAtEdge returns either true or false. This is exactly what we need for the condition, something that returns true or false. This won't work with a void method or a method that returns an int, only one that returns a Boolean. One key to understanding this is to read it in English. If it's true the crab is at the edge, then turn 17 degrees clockwise. What about the move statement? Since it isn't inside the if statement body, it has no relation to the if statement and executes each time the act method is called, no matter what. If the crab is at the edge, it turns, then moves. If the crab is not at the edge, it just moves. Let's place the move statement inside the body of the if statement. Now, let's see what happens when we run the scenario. The crab doesn't do anything. The reason is, now our code says, if the crab is at the edge, turn and move. The difference is, this time move is conditional. It's part of the if statement, and the only time it executes is if the crab is at the edge. Now the only time the crab does anything at all is if it is at the edge already. The scenario won't work correctly even though it compiles and runs. This is referred to as a logical error. It runs, but not the way we intended. For the crab to move the way we want, the move method should execute every time the act method is called, not based upon a condition. When viewing the source code in Greenfoot, notice the different background colors. These are used to show scope. Scope is the area in which something within our source code exists or is available. In Greenfoot, green is used to show class scope, yellow for method scope, and purple for if statements. Coloring helps keep track of curly braces too, as open and closed curly braces define the scope for each of the previously mentioned elements. Always remember to match curly braces. Also, use proper indentation and spacing to make your source code more readable. Java doesn't care, but humans reading the code do. Standard indentation is 4 spaces and can be achieved with the spacebar or the tab key. Notice how turn is indented inside the if statement. It lives inside the if statement, so we indent it to help show this. Another way of saying this is, turn has scope inside the if statement. Notice how move is indented inside the act method lined up with the left edge of the if statement. This is because they both live inside the act method and as such have the same level of indentation. Notice how the act method is indented inside the crab class. Same principle.